A very good day to madam. I'm Ho Yunshen and my metric number is 278611. Now I would like to present the application of differentiations, which is to find the minimum or maximum value and find a critical point for a function.
Minimum or maximum value is used to find minimum or maximum area of a location or shape. It occurs when dy over dx equals 0. And before finding its minimum or maximum area, the formula for the location or shape must be known first.
Here are the steps to find maximum or minimum value.
First, find the equation and do the first derivative test. Next, let dy over dx equal 0. Find the value of x. Then, do the second derivative test and substitute the value of x to the equation. If the value is negative, then it is maximum value. If the value is positive, then it is minimum value. From the questions, we can know that the security fence is not needed on one side of the area. So let width equal x and length equal y. 2x plus y equal 1000. Y equal 1000 minus 2x. Formula for area is area equal x times y. Then substitute the first equations into this equation. X multiplied by 1000 minus 2x equal 1000x minus 2x squared. Next, do the first derivative test. dA over dx equal 1000 minus 4x. The maximum value occurs when dA over dx equals 0. So 1000 minus 4x equals 0. 1000 equals 4x. X is equal to 250. Substitute the value of x into the first equation, and we can know that y is equal to 500. To get the maximum area, use the formula x times y, and we can get 125,000 m squared. Of course, this value is the maximum value as the questions already mentioned, but we can also do the second derivative test. The answers will be negative, therefore, it is maximum value. Critical points are key in calculus to find maximum and minimum values of graphs. They are placed where the derivative of a function is either 0 or undefined. These critical points are placed on the graph where the slope of the function is 0. All relative maxima and relative minima are critical points. To find the critical point for a function f of x, first we need to find value of x by f prime x equals 0. Then substitute x into f of x. Next, determine the minimum or maximum value of the critical point.
Find critical point and determine whether its maximum or minimum value for f of x equal x cubed minus 6x squared plus 9x minus 8.
First, differentiate these functions and we get f prime x equal 3x squared minus 12x plus 9. Then find the value of x by f prime x equal 0 and we get x equal 1 and x equal 3. Next, substitute the values of x into f of x. When x is equal to 1, f of x will be negative 4. When x is equal to 3, f of x will be negative 8. So we can know that critical points of these functions are 1, negative 4, and 3, negative 8. To determine the minimum or maximum value of the critical point, we need to do second order differentiations. Therefore, f double prime x equals 6x minus 12. Then substitute the values of x into the equations. When x is equal to 1, f double prime x will be negative 6, which is less than 0. Therefore, it is maximum value. When x is equal to 3, f double prime x will be 6, which is more than 0. Therefore, it is minimum value. We can conclude that critical point 1, negative 4 is maximum value, and 3, negative 8 is minimum value. To find the critical point for a function f of xy, which has two variables, we need to find partial differentiations for f of xy. Then assign each partial differentiations with 0. Two equations will be formed at this step. Next, find the value of x and y by solving the equations and we will get the critical point. Then do the second order partial differentiation to determine the minimum or maximum value of the critical point.
Find critical point and determine minimum or maximum value for f of xy equals 6x squared plus 3xy minus x plus 2y squared plus 3y minus 7.
First, we need to find partial differentiations for f of xy. If we take the partial derivative with respect to x, we will get 12x plus 3y minus 1. And if we take the partial derivative with respect to y, we will get 3x plus 4y plus 3. Now we need to find the value of x and y. The first equations plus second equations equal 0, and we get x equals to negative 7y minus 2 divided by 15. Next, substitute x into the first equation. 12 times bracket negative 7y minus 2 divided by 15 bracket plus 3y minus 1 equals 0, and we will get the value of y is negative 1. Now we have the value of y, so we substitute y into the equation. X equals to negative 7 times negative 1 minus 2 divided by 15. X is equal to 1 over 3. Therefore, the critical point is 1 over 3, negative 1. Then, do the second order partial differentiations to determine the minimum or maximum value of the critical point. We get 12 and 4, both are positive. Therefore, the critical point 1 over 3, negative 1 is minimum value.